Okay, guys, that topic that is the last topic of grade 12 in the last paper, paper 2, Euclidean Geometry. I'm just going to do a quick rundown. My first hour, I want to do a quick rundown of grade 11, just to touch. Then, if possible, I'll do the two theorems of grade 12 today. Then we start applying them and doing activities in our next session. So, it's all about theorems, but the bulk of the marks come from grade 11. And I know many of us hated the grade 11 section, which is quite easy. So, and that's we need to carry on. So before I go ahead with my grade 12 theorem, like I said, I'm going to do a recap. And my recap is not the conventional recap that I'm going to do. All right. A recap of grade 11 theorems. Let's see if we can look at the recap for 1 hour or 45 minutes, and then jump into the grade 12 theorems and try to put everything together. Then we know we are only left with activities. Now, a quick way to remember your grade 11 theorems. I wonder you have the note already, so you can just follow through. I use this X doctors. All right, doctor is DR, right? Right, Benja? Doctor, DR. Okay, doctors. And then unfortunately, this one's in Cape Town. How do you write Cape Town? CPT. Then I say +1. These are all your theorems. X doctors in Cape Town +1. Quickly, I'm going to look at each letter. Number 1, the X. So let's start with the X. I'm going to touch every single theorem, even more. When I see an X, two things come to mind. Vertically opposite angles. Vert up angles. And I can also use angles on a straight line. I hope you understand vertically opposite angles. So whenever I see that X thing, I'm going to think of that. And we are done with the first one. You see what I mean by we can be done as quickly as possible. When I see X, vertically opposite angles. Now, number 2, the D stands for diameter. The D stands for a diameter. And when I see a diameter, please understand the diameter must pass through the center of the circle, which means it divides the circle into what? 2 equal halves. When I see that, what theorem comes to your mind? Grade 11. Angle in a circle, and that's 90 degrees. So when I see a diameter, I'm thinking about what? Angle in a we can write it like that. Half circle. Or angle in a semi. And what is the value of that angle? 90 degrees. 2 things I want to think about here. Or 3 things. That is number 1. Number 2, what do you notice? What type of triangle am I forming? I'm forming a what? A right angled triangle. And what does that remind you of? That should remind you of 2 things. The theorem of Pythagoras and your SOHCAHTOA. Don't say this is not trigonometry, it's maths. So they can bring in trigs here. I actually have a question where they brought in trigs.
I still haven't gotten my question.
Which one?
And cos theta is equal to a quarter.
Oh, really? You must remind me. You must remind me. I've got a question here where they brought in, lovely one. They brought in a double angle formula.
Oh, wow.
Yeah, beautiful. Beautiful. So, but anytime I see the D, diameter, please, this is what I think about. So you need to know these things and quickly walk through. All right. Angles in a semicircle, right angle, triangle, Pythagoras, Socrates. That's all I'm thinking about. Number 3. What are we looking at? R. And what is the R standing for here? The radius. Thank you very much. Oh, you are on top of your game today. Radius. And look at what I am going to see when I see radius. I'm going to quickly draw my circle. Remember, the radius must come from the center of what? The circle. Please check. The radius must come from the what? Center. And that is the key word. Hello? Somebody saying something there? Unam, talk to moi.
Sir, can you please go back to the previous notes?
All right, Nana. So I was saying, once I see a radius, I know that the examiner is going to the center. And there's only one theorem that comes from the center.
One, sir.
Okay, 2.
Maybe one.
No. Are we okay, Unam?
Yes, sir.
All right. Center. What theorem? Do you remember? Angle at the center.
2 times angle of distance.
Beautiful. So once I see that, I know that there's an angle at the center. And which one is bigger? Learners always get this one confused. Which one is bigger? The one at the center. So that if this one is theta, what is this one? So we are looking at what? Angle at center is equal to what? 2 times angle at what? The circumference. Now there are 2 more things I want us to think about. There are 2 more things. This is a radius. That's a radius. Always look out for this. This one will be there. Once you see that, we form an isosceles triangle such that this angle is equal to what? That angle. So if I were to bring that out, look at what I am looking at. I'm looking at something that looks like this. Where this angle, and what are you going to say? Angles opposite equal what? Sides. So once I see that radius there, I know that that thing is close by. Angles opposite what? Equal sides. Are you aware that angle in a semicircle is also from here? Angle, you're not aware?
No, I think I forgot.
Angle in a semicircle. Wait. If I say angle in a semicircle, what's the angle at the center? That's 180. What's half of 180? 90. Angle at the center is 2 times angle at the circumference. But I want to draw 2 diagrams for you, which are very key. 2 important diagrams. First is this one. This one is the most confusing one, and I want you to be able to get it. Which angle are we referring to? The outside angle. Very, very crucial. Once you see that triangle like that, please, it is the outside angle that we are referring to. Another one is something that looks like this. Oh, by the way, this proof is examinable in the exam. All of them have to do with the radius. I don't know if you see that this is radius, that is radius, radius, and radius. We must know this proof. Let's do the proof quickly. Can you prove it? Do you guys remember the proof? All right, people are looking at me with one bombastic side eye there. The proof. Anybody remember the proof? This is examinable. Yes, absolutely. Let's do the proof together quickly since we are revising. Given a triangle. So I'm given a triangle like that. I tried to do some reels on this one. It's all available there. YouTube, Instagram, whatnot. A, O, B, and C. Prove that AOB is 2ACB.
And then there's constant between CO and
Yeah. So you've got to do a construction. Do you remember now? What's the construction going to be? Okay. We should join. All right. I'll say join, but extend it. Okay. So that's your construction. Construction show with a dotted what? Line. Okay. So let's call this P. We can call it any letter. Doesn't matter. Whatever letter that comes to your heart on that day, just write it. Now, what does that make? It means we have two triangles now, right? So it means I have, this is my radius. Is that fine? Then I can write this one as C1 and C2, O1 and O2. Can we then start by saying, again, remember what I told you? This is now an isosceles what? Triangle. Please always write your construction. Construction, what are we doing? Join, let's say COP. Is that fine? Different writers but mean the same thing. Join COP. Now, angle A is equal to angle what? C1. Angles that are opposite equal what? Sides. It therefore makes this angle. Those are now, we go back to grade 9. Exterior angle of a triangle is equal to sum of opposite what? Interior. So it makes angle O1 therefore to be what? Let me do this. Angle A plus angle C1. Exterior angle of triangle is equal to what? Sum of opposite interior what? But didn't we say A is equal to C? So we can replace it by saying O1 is what? C1 plus C1. And that is 2C1. Please make sure, if you can just go through the proofs like this, the way we are going to understand it, then you don't need to cram this thing. Similarly, whatever happens on the left-hand side happens on the right-hand side. So we can conclude that angle O2 will also be equal to what? 2C2. Now, what is AOB? Angle O1 plus angle what? O2. 2C1 plus 2C2. And that gives us 2C1 plus C2. And if you look at C1 plus C2, it's actually what? A, C, B. 5 marks. Please don't wait for the night before exam. Randomly, just learn to prove these things. Do we remember? Guys, do we remember this proof? This one is examinable, that's why I'm proving it again. So that it's on record that you were told.
And the rest, is it only this one?
No, there are 4. There are 4 that is examinable. So you'll be learning 6 proofs in total. 4 from grade 11 and 2 from grade 12. Please, this is one of the proofs that is examinable. Can I move? Where were we? R. Hello. Questions? Venusia, your hand is up.
Sorry, sir, that was a mistake.
Are you okay?
Yes, sir, I am.
All right. Okay, can we move on now? So whenever you see the radius, how many things are you thinking about? 2. What are the things you're thinking about? Angle at the center. And what? Angles opposite, equal side. I'll remind you of all of these things. What's our next letter? DRS. Okay. S. We're going to talk about same. And I'm going to also use equal. Now there are 3 that I want you to see from here. 3 different things that I need you to see. Center of the circle, center of the circle, center of the circle. Now this is the butterfly one.
Is this for equal chords?
Here we say angles in the same what? Segment. So we're saying these angles are equal. Why? They come from the same what? Segment AB. So what's the is it here? Angles in the same what? Segment. Okay, what are the variations? What are the variations? Because we're using the word same or equal. So I'm going to have 2 different chords. Now I want one white. I said I want one white and one. There we go. Now, what is the thing here? If those chords are equal, then those angles will also be what? Equal. What's the theorem here? Equal chords obtain what? Equal angles. Oh, I should actually draw 4 circles here. Starting. Do you know the 4? Equal chords obtain equal angles. Okay, I'm going to draw another circle here. There should be 4 because I don't want to combine all of them. Now, this one is similar to that one on top there, only that we're going to have this. What do you notice here? Or what would you say? Equal chord. The chords are equal, right? Subtends what? equal angles, but where are those angles? They are at the center. Equal chord. Can you see I'm using the word equal? The first one I used the word same, right? But the rest, it's equal, equal, equal. And I'll draw the last one. Do you guys remember the last one? What is the last one? The last one would involve two circles. Two circles. But the question is, how do I say circles are equal? When would circles be equal? When? When they have the same radius. So if for example, I'm saying draw two circles of 5 centimeters. What do they mean? It means those circles are exact copies of each other. All right? So R1 equal to R2 means that these circles are what? Equal. Basically, we are going back to this theorem that is above and splitting it.
Oh, because equal, okay.
So now I draw that and then go to the circle that is equal and draw the same, just reproduce. If this is equal to the other chord, then this angle will also be equal to that angle. So basically we are drawing two equal stuff, but they can mix it together. So what do we say? Equal chords in equal circles subtend what? Equal angles. Equal chords in equal what? Circles subtends equal what? Angles. And when I'm done, I'll be showing you, I have about 10 points that I need you to know on how to get Euclidean done as quick as possible. 10 of them. Equal chords, but those 10 are not going to work if you grab them. They don't work if you don't know the theorems, because the theorems are the reasons. And if you notice, I'm just using that acronym, X doctors in Cape Town. So this one is S, right? Are we okay, guys? There are 4 of them. Angles in the same segment, equal chord subtend equal angles, equal chord subtend equal angle at the center. Let me put this here. It's always necessary to show that these angles are equal. Then equal chords and equal circles. I think I've only seen about 3 questions where they were asking about equal circles. And I'm going to find those 3. So far, if I remember, 3 or 4. I'm going to find them for us to be able to use them. Any question? Are we good so far? This is grade 11, but please, your Euclidean is what, 35 marks? I'm lying, 45 marks. And grade 11 is about what, 25? If I'm right, yeah. Because you have your question 8, which is 10 marks, or 12 marks, and that one is grade 11. Which angles are equal to that? Which angles are equal to X? List 5 angles. Those are baby things that everyone needs to get. Then you move on to the grade. You move on to the proof. Proof is 5 marks. Then you move on to proportionality. That's where there's real maths. Okay, can I move on? Because I want us to do our 2 theorems today. Let's do all our theory today. Okay, what's the next one? C, which is what? Cyclic quadrilateral. Cyclic. Something is wrong.
Yes, sir.
It's right.
Yes.
You sure?
Yes.
ChatGPT, could you please check if my spelling is correct? Yes, Mr. Bishop, your spelling is absolutely correct. Thank you. Okay. Yeah. You know how you write and it looks odd? I feel it odd right now. Okay, cyclic quadrilateral. Now, please, one thing I want you to see is this. The four vertices rests on the what? Circumference of the circle. If it's not resting, it's not. And they won't tell you that's a cyclic chord. Once you notice that the four vertices are resting on it, then you can simply conclude that it is a cyclic quadrilateral. And there are three theorems that I need us to remember here. Three theorems. I'm going to join all of them because I want this one as well. You must learn the proof if it's examinable. Three theorems. Do we know them? Number one, opposite angles. And this is a common one, right? And when we say they are supplementary, what do we mean? Adds up to 180 degrees. Number two, the exterior is equal to what? Opposite interior. Exterior angle is equal to what? Opposite interior angle. Please, I'm going to come back and explain exterior angles. The line must be a straight line and it must be extended. And number three, angles in the same what? Segment. That's why I have the dotted lines there. So if you notice, this angle will be equal to what? That angle there. Because they are coming from which segment? And that's one way to actually prove this theorem. Okay, somebody's going to think I canceled that out. I didn't cancel it out. Angles in this, and I'm going to use this one to prove that opposite angles are what? Supplementary. Good. We need to prove quickly, everybody. This one is also examinable. Remember I said there are four. This is the second one. What was the first one? Angle at center. And basically I use angle at center to prove the rest. Angle at center. Number two is cyclic quadrilateral. Opposite angles are supplementary. Let's do the proof. And again, just by listening, hello, what are you still writing there? Just by okay, make it fast. Just by listening to the proof, what I want you to do is, guys, please practice. Don't wait for exam. Just practice. Determination. Every Monday I prove this one. Every Tuesday I prove that one. Every Wednesday. Every Thursday. There are 6 of them. You have 7 days in a week. So you have 1 day to rest. And it takes you about 3 minutes. In fact, you don't need to do it consistently. What are you saying there? You just need to do it for 3 weeks. And then you master it. Can I move now?
Yes, sir.
Okay. All right, let's look at the proof. Proof that the two opposite angles are what? Supplementary. They add up to 180. Center of the circle. Which one do you want us to prove? A and C, B and D.
A and C.
Okay, you like politics. I see. Prove that angle A plus angle C. I want to tell you the secret why I was asking. And I'll put a note here for you. Since they want me to prove angle A and C, make your construction. Make your construction on B and D. That's the whole idea. Nope. Using angle at, and once I say angle at center, what are you constructing? Radius. But I'm going to use what? B and D. I know it looks as if it's almost perfect, so just I want to shift that a bit to say that's my center. Even if it's straight, it doesn't matter. So I'm going to construct what? I'm going to construct B. And if you look at that already, please look at my highlight. You would notice I'm already done. That angle at center. And if you notice this one as well, that's the second diagram where I spoke about the reflex. This and that. So if we then label as O1 and 2, what can we then say? Let's start with our construction. What are we going to say? Join radii. Which radii? OB and OD. Look, for you to see it closely, I'm going to try to draw the triangle I'm focusing on out. Look at this triangle. I don't know if you can see that triangle. That's my B, that's my D, O1, and C. What do you notice? I don't know if you see that. That angle at what? Center. So can we say that, what is this, O2, right? Angle O2 is equal to what? 2C. Angle at center is equal to 2 times angle once I get the first one correct, then I'm good. I'll just reverse it now. O1 must be equal to what? 2A. Again, angle at what? Center. Beautiful. But O1 plus O2 is equal to what? 360. Angles around a point. But what is my O1? 2A1, 2A plus 2C. Oh, can I divide everything by 2? What do I have? And that's the proof. We're done. So easy. So easy. Sorry, Crazy, I'm only seeing your message now. Which angle are you referring to? You said angle A is D1. What do you mean here?
The ones that you had, the circle before you had.
Before this one?
Yes, sir. The ones where you had circles, you remember those small circles?
Wait, I need to make sure that we're having the same information. This one?
Yes, sir.
Okay, big.
Those small circles by angle A and angle D, does that mean they are equal?
Yes, they are equal.
Okay. Thank you, sir.
Angles in the same segment, they are equal there. Again, this proof is examinable. There are 6 of them. That's a number 2 proof. And remember, there are 3 points here. What are the 3 points? 3 points. Opposite angles are what? Supplementary. Number 2. Exterior angle is equal to opposite interior. And number 3. Angles in the same what? Segment. I could use that to prove a cyclic quad. Have you seen that before? Have you seen that before? Using angles in the same segment. Really?
Which one is angles in the same segment?
It's so cool.
What's angles in the same segment?
Okay, let me use it to prove. That one is. Can I move, guys? Let's just have a bit of fun. It's becoming too heavy. Let's have a bit of fun. Look here. Oh, wait. Why am I doing that? Let's do this. I want to prove the same thing. That A plus C is equal to what? 180. But I'm not going to use angle at the center. I don't even need a center. Look at what I'm going to do. I am going to join A and C, and I'm going to B and D. Let's label A1, A2.
Oh, angles in the same segment.
Yeah.
A1 is equal to B1.
B1, B2, C1, C2. Are you with me? Okay. We can use letters to make it quite easy. Let's use letters to make it easy. Let's use P, Q, R, S. P, Q, R, S, T, U, V, W. Are we okay? All right. Since it's angled in the same segment, I'm going to highlight for you this angle should be equal to what? Does that make sense? Do you agree? That this angle, so can I do something? Can I change this to P? Would it make sense if I do that? Do we agree? Are we good? I want us to limit it to just 4 letters. Again, I should have actually done that from the beginning. Can you see that, right? So they are equal. All right. What about Q? Let's trace angle Q. I'll give you the secret. That's Q. Do you notice that's also Q? Okay. Just let me know at any point where you feel lost. That's also Q. Because this and this are equal. So I've got P and Q. What about R? Yes, I can use R. Is it okay to say angle T? I can change this to R.
It's U.
Am I correct? No, sorry, it's U, right? U. I should write R. That and that are equal. What about Q?
W.
Yeah, W. So we only have 4 letters. What letters? P, Q, R, and W. Okay. This one I won't write a write-up just to show you. But this is a quadrilateral. And what do we know? A quadrilateral should give me what? 360 interior. How many R's do you have? 2. Okay, so we are saying, let's do this. A plus B should be equal to what?
I say you're going to go.
You see where I'm going?
Yeah.
This is P plus Q. What is B? R plus P. What is C? W plus R. What is D? W plus Q equals to what? Now, there's a P here, there's a P here, there's a Q here, there's a Q here, there's a W here. So what do you notice? They are all 2, 2, 2. So 2P plus 2Q plus 2R plus 2W Can we divide by 2? What do you have? P plus Q plus R plus W. Where's your P and Q?
No, it's equal to 180.
Oh, 180. What's your P and Q? Do you notice that's A? What's your R and W? That's C. And the same way, B and D will also be equal to what? Because I just need to rearrange.
Yeah.
B is R and P. All right. So that's just to prove to you that when we say angles in the same segment, we can use it to, when we say what are the properties of what? A cyclic chord. That we mention angle in the same what? Segment. That's it. So this is using angle in the same segment to confirm that a quadrilateral. Oh, well, I have not seen this in a memo. So that's why I didn't want to do the full proof. Because I don't know if I see this in an exam, I would accept it if I'm marking. But when we go to the marking center, the typical wouldn't know math there. There's nothing that discredits what we've done, but it's not, the one that is mostly approved is the first one we did. Okay. All right, let's move. We're moving well. I like the pace. This is grade 11. What's next? What's our next letter? Huh? P. P for Papa. Parallel lines. Okay. Parallel lines. This goes way back to grade 8. And it's always funny how the grade 8 cannot just see it. And it's funny in grade 8. It's terrific in grade 12 when somebody cannot see those parallel lines, like it's right in front of you. Okay, can we look at P quickly? Parallel lines. If there's any note you missed, you can just take a picture. But I'm just trying to quickly do grade 11 theorems. And I did send a video on the group as well. You can rewatch that again. You know, it's very important. Parallel lines. What are we thinking about? Fun angles, right? And what are we saying? The F, these two lines are parallel. What are we saying? Alternate what? I'm lying. Corresponding what? Angles. What's next? And what do we know about co-interior? Co-interior angles are supplementary. And the last one? Alternate what? Angles. Remember, your alternate angles are in the curve there. Corresponding angles are right also in the curve. Co-interior angles, they add up to 1. Those ones are not equal, that's why I'm using different signs. And I think that's all about parallel lines, nothing more. Nothing more. It didn't change from grade 8. What's our next one? T. There's a proof on this one. Tan chord, and this is the most common that is tested. If they don't test it in proof, they'll test it in application. You can't escape this one, no matter how much you pray. Tan chord, and learners have an issue with seeing tan chord. The first thing is, what is a tangent? What is a tangent? Yeah. A line that touches the center just what? Once. If it enters, it's no longer a tangent. That's a tangent there. And do you remember the 3 theorems here? You've forgotten? radius and tangent are perpendicular. Number one, what do you have? Tan perpendicular to what? Radius. That's very, very important. When I see that, you know what I also consider? Pythagoras. So I also, because that gives me what? A right angle what? Triangle. And when I see that, I consider Pythagoras and what? SOHCAHTOA every time. That's our first circle there. Tan and radius are perpendicular. And this will we are going to come back to this in analytical geometry. Because the gradient, the product of the gradient must be equal to what? -1. If two lines are perpendicular, then MR times M tangent must be equal to what? -1. So can you see we're infusing that again now? All right. Can I move on? I have two more to draw, two more circles. Let me wait 2 seconds. Guys, after doing this, you know what I'm going to do? I'm just going to jump into the grade 12. At least let's do one. Even if it is one. Let's do one. Then, I'm going to do... Okay, let's do one grade 12 theorem today. We'll do activities on grade 11. Okay? But I want us to at least touch on one grade 12 theorem. Are we still writing? Give me a thumbs up if we can move.
The other two is tan chord and equal tangents or something like that.
Which one?
The other two.
Yeah, there's tan chord and then tangents run from the same point. All right, I think, who gave me a thumbs down? I think it's Unam there. I'm not sure. I know that there was a thumbs down. And I want to quickly train you. Can you hear me now? Okay, thanks for letting me know. All right, tan chord. Now, this is what I'm going to ask you to always look for. When you see a tangent, there's an angle there. And this is my chord AB. So chord AB is very important. If this is theta, so chord AB is making an angle of theta with the tangent. We need to chase chord AB again and see where it goes in the circle. And that's your tan chord. All right. The angle between a tangent and a chord is equal to the angle subtended by the chord in the alternate segments. Alternate segment means it's in the other segment. I'll explain that quickly. I'm going to use a highlighter. Guys, if you look at this angle, you see a chord would divide the circle into two segments. This is one segment, and that's the other one. But this angle made is in one segment. The angle we are referring to must be in the other segment.
Similarly, with equal chords subtending equal angles, it has to be in the same segment.
Yeah, this one, that one will be the same segment.
It can't be in a different segment.
Yeah. But this one must be in the different segment. That's very important, especially when they ask you to complete the statement. Can you prove this? Can we prove it? So this is our third one, right? But let me do the third theorem, then prove this one. What's our third one? Tangents drawn from what? Same point. Are what? Are equal in length. Tangents drawn from the same point are equal. So we're saying that AB tangents drawn from common point. And I can get a cyclic quadrilateral from here. I can get a cyclic quadrilateral from here if I have that, and I draw a radius. If I draw a radius, so if that's a radius and a tangent, 90. And what do we know? Opposite angles, if they are supplementary, then it's a cyclic quad. So that's a cyclic quad there. Beautiful question there. All right, please write that quickly and let's go proof. We're running out of time. Remember, I want to prove one. I want to open you up to one grade 12. So I need to increase my pace now. I want to throw you to one grade 12. Are we done? First thing is to prove, right? What are we proving? Proving the tan chord. Proof of tan chord. Proof of tan chord. Can I move on? Is there anyone still busy? Give me a thumbs down if you are still busy. And if you are done, thumbs up will be appreciated as well, because I'm checking everybody. All right, I've got a thumbs down from Bukudo. Bukudo, I'm going to wait on you. Once you are done, please give me a thumbs up. I'm waiting on you. Sweet. Proof of tan chord. Let's prove tan chord. Let's call this P. Prove that angle ABP is equal to angle ACB. Guys, again, I'm going to try to draw. If I have to prove, you don't do construction on that angle. Please, again, more than writing, just listen to, because this proves you have there, but put a voice over it. If I have to prove, you see, I'm proving angle C, right? Don't make a construction on angle C. The angle you are proving, don't make a construction. There are two ways to prove this, but I want to use angle at the center. Should I use that one? Which one is easy? I have my center. Let's construct a diameter. That one is quite easy. Alright? Let's construct a diameter. But remember what I said. Let's call this D. Don't construct on angle what? C. So what would I do? I'll construct on angle what? A. By drawing a diameter, so my construction, construct diameter, what? B. What did we say about the diameter? One of the angles, so with angle in the semicircle, right? It means angle A already is what? 90 degrees. Okay. Let's call this B1 and let's call this B2. Or I like to use X.
Yeah, you used X.
Yeah, I like to use X there. Okay. So, let's find, look, your aim is to find angle D. Is that okay? Your aim, please, I want you to follow this. Remember, what is this? A radius. And what is that? A tangent. So, angle OBP equals to what? 90 degrees. Tangent perpendicular to what? Radius. What do you think B2 would be? 90 minus X. So, angle B2 therefore is what? 90 minus X. Because this is 90. But I know this small part as what? X. So that is what? Wait, I already know this as what? So what is D? D is X. Sum of angles in A. Wait, somebody's not seeing why that is X. D plus A plus B2 equals to what? 180 degrees. I'm looking for D, right? What is A? 90. What is B? B2. 90 minus X. Do you notice 90 will give me 180, which cancels that out? So if I move the X over, so angle D is equal to what? Angle X. Sum of what? Angles in a triangle. Oh, angles in the same segment. Angle C, therefore, equals to angle D. Angles in the same what? And I am done. That's the aim. I wanted to prove that those angles are equal. Can you see that, therefore, angle what? What is my C? It is ACB equals to what? Because this is X, that is X, and that is what? X. Please, all of these proofs are 5 marks. Very, very important. We have one more to look at, and then I jump to my grade 12. I jump to my grade 12. Okay, are we done? Guys, I need to move. I need to get the grade 12 in quickly. What are we left with? Theorem 1. Theorem 1. Line drawn from center, perpendicular to the chord, will do what? Bisect the chord. Or line drawn from center that bisects the chord is perpendicular, and you must know the proof. That's the fourth one. Yeah, and that one is where we bring in our grade 9 knowledge of congruency. 4 proofs. I don't know how I remember all of this. Okay, can I move? Last one. Theorem number what? 1. I don't know these things by number because it's not conventional. I only know theorem 1. What are we saying? A line drawn from where? Center, perpendicular to the chord, will do what? Bisects the chord. Please, the proof of this one makes it number 4 proof that you and I need to know. A line drawn from center, perpendicular to the chord, will do what? Bisect the chord. Can we prove this quickly? If you remember the proof. Okay, so if I want to prove that, let me draw another circle because already I've made a conclusion there. So I want to draw a circle where I have no conclusion. That's what I have. What are we proving? Prove that AC what are we constructing?
OA.
Construct OA and OB. Remember, dotted lines to show construction. Okay? Construct what? OA and what? OB. Now I'll say OA is equal to what? OB. Radii. Is that fine? Let's call this angle 1 and 2. Angle C1 is equal to C2, 90 degrees. And that was given. OC is common.
We did not say angles in a straight line.
No, because they gave me that one as it's given, so it's fine. So if you notice, it is side angle. If you notice that, and that's congruency. We're still going to go back to congruency. I'm going to repeat congruency very soon. Side angle what? Side. It means those two triangles are exactly what? The same. So I'll come and say triangle. Please, the way you label is very important. I will be emphasizing that. OAC. I must start with O. Triangle what? OBC. Move the same way. Side, angle, side. Therefore, AC is equal to what? Because already, since we said they are congruent, this is equal to that, this is common. For them to be equal, that will be equal to that, and we are done. Third proof, or fourth proof that you need to know. Please, guys, I sent you a video on the proofs. During the holiday, sit with it. Learn the proofs. Once you know the proofs, it's easy to, Euclidean becomes the easiest. Do you know this is easier than algebra? Algebra can be very nasty. It can be your friend. But as you go down, it can be nasty. Let's not even compare this one and trigonometry. This is the fun part of maths. A line drawn from center perpendicular to the chord will do what? Bisect. Do we know the converse? What is the converse? Also learned, oh, by the way, they started asking for the converse, the proof of the converse. Yeah. It's now examinable. I wish you could see your face. What's wrong? The converse is now examinable. But it's the same story. Can we do the converse quickly? It's now it's fresh. Only this one used to be examinable before, but that is now examinable. Okay, let's do the converse quickly. I'm looking at my time. Theorem 1, converse. Ooh, your face. You made my blue Monday. What is the converse? A line drawn from what? Center. That what? Bisects the chord. Now we are looking for the angle. Is what? Perpendicular. You see, we are trying to prove that the angle is what? 90 degrees now. We are now trying to prove that the angle, most of the time converse is used when you are proving the angle. Okay, guys, please listen again. I know this lesson we're moving quite fast because it's grade 11, but you've got to just go master this again before school opens, and then use the one done at school for revision. Okay, so what are we doing? A line drawn from center that bisects. Okay, we have it as that. Now, what do we want to prove? We want to prove that C1 equals to what? 90 degrees. We're just going to reverse the whole situation. But our construction will still remain what? The same. What are we constructing? OA. So let's do that together, everybody. Construct what? OA and what? Remember now we don't have an angle. So we cannot use side angle side. But check. I'm going to say OA is equal to OB. What's your reason? Radii. OC is common. AC is equal to AB. Given. Do you notice? AC is equal to BC. Side. If the three sides are equal, then the triangle is just a photocopy of each other. Therefore, triangle what? OAC is congruent to triangle what? OBC. What's your reason? It means these things are exactly what? The same. If they are so, it therefore means angle C. That's why the order is important. Look at the order. The angle O in this is equal to the angle O in that one. The angle A in that is equal to the angle A in that one. Angle B. Okay? That's why the order is important. Therefore, the C's are also what? The same. So C1 is equal to what? C2 because of congruency. But what do you notice? C1 plus C2 equals to what? 180 degrees. Angles on a straight line. Oh, therefore. And that's what I want to prove. 90 degrees. So you see it's the same. But now we don't have an angle. We are looking for the angle. The other one, we had an angle and we had to use side angle side. So this is all grade 11. Can I move to grade 12 quickly? Just one theorem today. All right, let me know if we're good. Because before I do that theorem, I need to do some explanation. Are we ready? All right, so everything we're doing was just warming up. Now let's go to the grade 12 one. Okay, even if we don't look at an activity today, it's all good. Now, my grade 12 theorem, grade 12. That's my Afrikaans coming out now again. Now, before we jump into the theorem, there's a theory that I need us to quickly go through. It's called the theory of parallel lines. Okay? The theory of what? Parallel lines. Now, if I have two lines that are parallel to each other, it means that their height between them, when I say height must be vertical, right? Remember? Their height between them are the same. That's height. Height must be perpendicular. So I have h1 and what? They are equal. Because if they're not equal, then the lines are not going to be what? Parallel. Okay, so please, I want you to get the build up. Okay, that's my first thing. Are we okay there? If I then consider two different triangles of the same base, consider two triangles of two, let me say two different, I want us to see, two different what? Triangles of the same base within two parallel lines. Where are we going with this? Please, this is the build-up. This is very important. Consider two different what? Triangles. Okay, I'm going to quickly draw this thing again for us. Let's use white. I'm going to draw the parallel lines again. Make it big. Yes, talk to me. Lemo, talk to me.
Hello, sir. I can see the green.
There are three crazy physics there. I sent you a message. There are three crazy physics there. One is the presenter, one is the audio, one is the video. Check the participants and keep trying the crazy physics. Let me know quickly.
Because it green comes and then it goes like all the time. It shows and then like after 5 minutes it goes.
It's probably your network, I don't know. Guys, is the screen visible?
Okay.
Okay, try that and pin it. Let's see. Double click to pin it. Double click
It's
to...
already pinned.
Okay, so can you see it now?
Yes.
Okay, let me know if it goes again.
Okay, thank you.
All right. Now, guys, let's look at, I want to have the same base, AB. I'm going to construct a triangle. Let's call it a green triangle. And I'm going to construct a yellow one, but they'll be very different. Those are different triangles. Okay. But the amazing thing is that they have a common what? Base. And they also have a common height. Because height is measured from the vertex perpendicular to what? To the base. Let's call this H green. And this one will be what? H what? Yellow. Remember, these two lines are what? Parallel. This is not a theorem. This is going to build to the theorem. What do you notice? HG is the same as what? H1. We usually use H1 and H2, but I'm using colors this time just to... Okay. What is the... Let's call this ABC. Good. Let's look at the area of triangle ABC. It is half base times what? Height. H green. What about the area of triangle ABD? Half, what is our base? AB. And what is the height? But we said HG and HY are the same. So what do you notice? The areas are the same. And that is the key to this proof. I don't know if that makes sense. Please let me know if that makes sense. If two lines are parallel, then the distance between them is the same. And that's what serves as our height. Unam, let me know where you are lost. Talk to me quickly, Nana.
Sir, please explain again.
Okay, keep your mic on, Nana. What is the area of a triangle? Half base times height, right? Half base. Can you see that?
Yes, sir.
That's a triangle there. So base and height. Okay, that's triangle 1. What about triangle 2? Same formula. Do you notice they have the same base?
Yes, sir.
And they have the same height?
Yes, sir.
Good. So if all of this and this are the same.
Yes, sir.
Half is half, AB is AB, HG is HY.
Thank you, sir.
Alright, so hence we say that what? The area of triangle what? ABC is the same as the area of triangle what? What's going to be your reason? They have a common base and equal what? Height. So if their bases are the same and their height is the same, area is the same. This is what's going to lead us to our grade 12 proof. Because I'm going to throw this into the proof somewhere. And that proof is so easy that the examiner will always lead you. Lemo, are you still fine?
Yes, I'm so fine, sir. Thank you.
All right. Okay, let's prove the grade 12 one now, quickly. The grade 12 theorem. Very, very interesting. Maybe I can look at one example on how to use it, because I see we have some time. Okay, what is the proof? That's the question. Okay, here is the proof. Given a triangle, given triangle ABC, let me draw that triangle first. So I'm going to have a triangle ABC. Please, I want you to just hold on writing. Get the proof. It's 5 marks again, or 6 sometimes. And now I'm going to have a parallel line. We spoke about a parallel line. In grade 9, we were putting it in the middle. Now we're just playing around. I can use any letter. Let's use P. P and what? Q. And these two lines. Please, I want you to follow the proof. Don't write at the moment. These two lines are parallel. Given triangle ABC, and given that PQ is parallel to what? BC, prove that. Now, there could be variations of this proof, but I'll start with the first one. AP over PB is equal to AQ over QC. Watch the movement. That's why I said, please don't write, I'm going to be slow. AP, the top part of the triangle, over what? The bottom part of the triangle is equal to what? AQ over what? QC. The examiner can move in any direction. Examiner can do this. Prove that AB over AP. So let me write all the variations for you. And they are all the same. All the proofs are the same. And I'll guide you. Examiner could say what? AP over AB. What will it be equal to? Do you want to help me? Please look at the movement. because you need to learn the movement. AP, the top. AB, everything. What should that be equal to? AQ over what? Beautiful, over AC. Examiner can say PB over AB. Check your movement. Bottom over everything will be equal to what? QC over what? All of them are the same proof. Same proof. Which one can we have again? We can turn it, reciprocate it. Doesn't matter. So here are the things that will help you remember the proof. Please, I want you to listen to this. I'm going to be very slow. 6 remarks. You don't even need to cram it. Yes, talk to me.
So the screen has disappeared again.
I think it's just try to look for it again. I don't know why it keeps doing that on your phone.
As I tried using a different phone.
And
What happened?
it still happens.
Yeah.
So I don't know. Maybe your network is quite. The strength is it's quite. I wish you could measure. You could do a network test. But all you need to do is just to keep logging in and logging out. Quickly log out and log in again. I'll wait for you. Just waiting for Limo to log back in. All right, Nana is back in. Can you see the screen now?
No. Yeah, I can see it now. Yeah.
Okay, all right. Now, guys, you're welcome. Listen, I want you to listen to what I'm going to tell you. When they give you these things, these ratios, please understand that they've given you the base of each of the triangles. I'm going to have to use 4 triangles. And all of this are already what? The basis of the 4 triangles. Let's use English. Basis of the 4 triangles. Okay. And I am going to be using the concept of what? Area. But for me to get area, I must have what? Height. Okay, so I'm only going to be using area, that's all. So let's prove. I'm going to construct. Remember, every time we construct, what do we use? Dotted lines, right? Please watch. I'm going to construct 2 heights. And I'm going to start from here. Make sure it is, you have to show that. Let's call this H1, H2. So I'm going to write my construction. What is my, please follow through. Construction, what did I do? Construct what? Don't just say height. Perpendicular height. H1 and what? H2. Everybody okay with that? Please watch my highlights. I'm going to use that. Now, what are we proving? AP. Here's what goes on in my head. And to even tell you, I didn't even read anything to come to this class. Right? Look at AP is the base. Where's my highlighter? Oh, so I'm using this triangle. AP is the base, right? It means that Q, please listen again. If AP is the base, Q is going to be the vertex. That's the top of the triangle. I'm going to highlight again, please. AP. Where's my vertex? What's the next one? What's my vertex? Q. Your vertex would always be the middle one. So I could, listen, I'm going to complete this triangle again. I want to repeat that. So which triangles am I using? APQ, BPQ. Everything is on P. Please let me know if you got that. Wait, let's go to the right hand side and then I'll ask you if you're okay. AQ is what? The base. Where is going to be my vertex? The vertex is always those lines. So what would my triangle be? AQP. Can you see that triangle? And what? QC what? P. Let me know if we are okay with that step so far. Let me know. The vertex is always the P. So make your notes. That's why I'm putting those notes. The note is that P and Q will be the vertex. And to help you see, I'm going to write this on the side. Our little cheat note would be to work with what? Triangle APQ over what? PBQ. Do you notice QQ there? If I move on to the right hand side, what would it be? AQ, what's the vertex? P over what? QCP. Are we okay? Once you understand it, there's no need to cry. And I'm working with what? Area. Okay, construction. Construct perpendicular height H1 and H2. Join, which line did we join again? PC and what? BQ. We okay? I'm done with my construction. One mark in the bag. Now, go to your triangles that you've labeled. What is the area? Area of triangle AP what? Q over. Remember, they gave you as over. So you to put over there. Are you with me? I'm going to highlight again for visibility. So keep your eyes on the phone. What do you notice? That's the height. Does that make sense? Okay. APQ, what would it be? What's my base? Half base times height, right? Half. What's my base? I told you whatever they gave you. AP, right? What is the height? H2. Over. Okay, half is there already. PB is there already. Don't even stress. Write H2 again. But let me show you. Don't even stress. Look at it. What are we looking at? PBQ. PBQ. Watch this. Let me draw it out for you so you can see. P. Somebody saying, how is that connected? Now, your height must always be perpendicular. Right? So for me to have a perpendicular line, we're doing this in grade 8. We used to extend this guy. And that's where I have my 90 degrees. Do you notice H2? But don't even, just rewrite H2. Do you know why? So that these things can cancel. And what do you have? AP. Already I'm done with the left hand side. I don't know if it makes sense. I'm going, look, similarly, let's do the right hand side. What do I have? Area of triangle what? AQ what? P over, do you want to talk to me? Area of triangle what? QCP. You can even predict that. What would it be? Half AQ H1 over what? Half QC H1. What would that give us? AQ over QC. The right hand side is done. What we are now going to do is to prove that the left hand side is the same. And to prove that, this is what you do. I'll put a note here. Proof. First we proved what? First we work with left and what? Right. Now you are going to work with top and bottom. What do I mean by top and bottom? What triangles do we have on top? Everybody, look at the triangles we have on top. Can we go trace this triangle out? What is it? A, P, Q. That's the triangle, right? And what? A. What do you notice? It's the same triangle. So if it's the same triangle, what happens to the area? It's the same. So I'm just going to come here and say what? Area of triangle what? The top APQ is the same as what? The area of triangle what? AQP. It is the same what? Triangle. Can we look at the bottom? Okay, let's look at the bottom. What are we looking at? Again, follow my highlighting. PBQ and what? QCP. Oh, these ones are not the same. Oh no, wait. Do you remember where we started? What are these two lines? Okay, watch this shading again. QCP and what? P. Oh, I wanted a different color before it fades away. Do you notice that the base is this? They have the same base. PQ, PQ. And they are bounded between what? Parallel lines. What happens to the height? Their heights are the same. Oh, so they have a common base, equal height. What happens to the areas? Same. Oh, 5 marks is now in the bag. Area of triangle what? PBQ is the same as area of triangle what? QCP. What are we saying? Common what? Base and equal what? Height. Common base means we're talking about the same letter. Oh, what did we say now? So area of the tops are equal. Area of the bottoms are also equal. Oh, so the top on the left is equal to the top on the right. The bottom on the left is equal to the bottom on. Oh, so can we make a conclusion? Therefore, since the tops are equal, AP is equal to what? AQ, because that's the area. And since the bottoms are also equal, what do we have? Equals to what? And no matter the letter they give you, you copy and paste the same thing. Just change the letters. Same reasons, same story with that. 5 beautiful marks there. First, whatever they give you serves as what? The base. The vertex is on the other side. I don't know if we should put those down. Wait, hold on. I want to write what I'm saying. What did we say? The ratio given represents what? The basis of the forward triangles. Number 2, what did we say? The vertices are on the what? Other side or opposite side. Maybe this would at least to help you remember. Opposite what? Sides. Are we okay? What next did we say? Number 3. Prove area of left hand side. And the keynote is this. Triangles have the same what? Height. Triangles on the left hand side will have the same what? Height. Remember it was H2, H2 there. Number 4. Do the same for the right hand side. Step 5. Prove the top. And that one will simply be what? It is the same what? Triangle. Prove the bottom. But 5 and 6 may change based on what they give you though. You just need to take note. Prove the bottom.
Oh, yes, yeah.
And what will be the reason? Common what? Base and equal what? Height. But take note, 5 may go to 6 and 6 may go to 5, depending on how the examiner puts it. And we are done. And we are done. The left hand side automatically is equal to the right hand side. Please learn this proof. It's very, very, this one I want to tell you. For June exam, it's always this one or the second one. You know why? I'm not saying in most cases, because they know you've been proving that one in grade 11. This one is fresh. So they want to test you on this one, in most cases. For June exam. But please, like I said, there are 6 theorems. Monday, Tuesday, Wednesday, Thursday, Friday, you're good. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, you're good. You rest until it becomes part of you. Yes, I know you want me to go back, now lady. There we go. Hi, Nana. Yes.
So can I ask, what if in the exam we are given, in like triangle APQ, we are given H1, and then we are told to look for the angle of H2, which is going to be 90 degrees. So what reason do we use
To look,
in that case?
they won't ask you to look for the angle.
Okay.
Every time we mention the word height, our height must be perpendicular to the horizontal. So every time if I ask you to measure, have you ever measured your height in the clinic?
No.
Oh, really? Child, don't you get sick? When they, oh, only few. When they put, I'm sure you've done it before, only that you've forgotten. You did it when you were a kid. Where they put a ruler on your head. If you move slightly, they push your head back. Why? They want it to be vertical. So every time we refer to the word height, height must be what? Vertical.
Thank you, sir.
All right. I know time is up, but I want us to do one question. Just one. Why are you? Why? One simple one. You will actually see that this is grade 9. Grade 9. You guys are laughing. I promise you that it's grade 9. Look at this. Okay, wait. I know you want me to go back. Just wait, people. Wait 1 second. I want to finish talking so that I can rest. And then you can write and take pictures. Look at this. I have P. I have Q. I have R. Don't worry, it's going to be very easy once I finish. Like next week, I'll be giving you 10 things you need to look for. 10. But I just want to show you how this is applied. I have 5. I have 2. I have 10. And I have X. The examiner is telling us to find X. That's the example I want to do. The examiner is telling us to find what? X. Already, I know. Oh, by the way, there's an error I did. This is called proportionality theorem. Did I write it? Oh, grade 12, number 1. Okay. This is called what? Proportionality theorem. It's about proportions. The side, This is completely grade 9. Grade 9, like 9. But you are not serious there. You didn't even know you were going to do maths. You were thinking, I'm doing maths late. But check. When do I use proportionality? I'll be telling you that next week. When I see parallel lines. Wait. Do you know that I could just come here and say PS the top over the bottom.
Yeah.
If I do that on the left hand side, can I also do that on the right hand side? What would that be? PT over what? TR. What is going to be your reason? Reason, you write prop theorem, and then you tell us the lines that are parallel. ST. That's the reason. Parallel to what? QR. Do you notice we are done with this question? What is PS? 5. What is QS? 2. What is PT? 10. What is TR? X. Ratios from, do you understand what I mean? 4, right? Because 5 times 2, it's a multi. We're done. 4 what? Centimeter. It is 1, 2, and 3. And that's the whole theorem. Are you aware that, let's check something. Will this be correct? Will I be correct if I say PS over PQ? You want to tell me the movement? PS over PQ? What would I have?
Oh, PT over PR.
PT over PR. It's the whole length. All right. Again, what would I write? Prop what?
Yeah.
Theorem. What are we looking at? ST parallel to what? QR. Let's see if we're going to get the same answer. What is my PS? 5. What is my PQ? 7. What is my PT? 10. What is my PR? 10 plus X. Let's cross multiply for the sake of people who don't believe. 5, 10 plus X equals to what? 70. Is that fine? Can we divide both sides by 5? What is 70 divided by 5? 14. What is X? So these are the variations we are going to come across. Okay, I wish it could be simple though, but these are the variations. The thing is, they'll just be mixing a whole lot of stuff. But if we can start looking at it from simple units, then it becomes a lot easy. Guys, are we okay? This is our first grade 12 proof. Not bad. Not bad. Remind me next week when I'm going to relook at this, but I'm going to then show you the midpoint theorem again. All I need to do is to move this line up to the middle. And it affects the ratio. But we're going to start from the midpoint theorem. Guys, any question, let me know. This was just an easy way of getting into grade 12 though. We are cruising.
When you move this up, then the top is equal to the bottom.
Yes. The top will be equal to the bottom. Then ST would be half of QR. All right, everybody. No questions? Did we get all the notes? Is there anyone who needs me to move back or whatnot? Yes. Yes, Mohammed?
So I think you're
Sorry? Where do you want me to go?
back to the thinking.
This one?
Okay, the slide before that.
Before you sleep tonight, just try to see if you can remember the proof again. You know? This proof.
Okay.
Just write it out. You know, the more you write it, the better. All right, guys, have a lovely evening. Let me know if you got all the pages, or I can open this one for you. All right, Mohammed. Any other body who needs any other page? Quasi, we good? Vokodo, we all right?
Can you please just go to the last slide? Just quickly take a screenshot.
The activity one.
Yes, sir.
Okay.
Thank you so much, sir.
All right.
Enjoy your evening.
Thank you. You too. Bye.
Bye, sir.
Bye. Hey, wait.